is the shield, this is the insulation, normally it's a plastic, and this is the center conductor. The center conductor is in two shapes, solid or stranded. Normally in marine application it's recommended stranded because we need more flexibility. Exactly the same like in our previous book with the marine cables. The marine cables are different like the industrial cable. The industrial cables are solid, our cables are stranded, basically for flexibility. Exactly the same with the coaxial cable. In relation with the impedance, we talk about the impedance. Those are the most common impedance in marine coaxial cables. We are going to use 75 ohms and 50 ohms. Both of them are commonly used in marine application. And depending on where is the cable and what is the function of the cable, we are going to use 75 or 50 ohms. I'm going to explain later with a particular example. If this is the cable, this is the shield, this is the isolator, this is the conductor, and this is the jacket. The shield is very important because I am going to explain later. We are going to bend that shield in order to introduce the connector here, and that shield will be the ground of the connector. If the shield is not properly bended, the connector doesn't have ground. Immediately the connector is introduced here. You can solder in through those holes. The shield, and additionally you can solder in the conductor at the end, like the picture that you have on the screen. This table is excellent in order to understand the most common coaxial cables and where are used. For example, for analog TV we can use both cables, RG59 and RGA. And for CCTV we can use those 4 cables. Yeah, and for satellite TV, those are the most common cables for satellite TV. This is for CCTV and this is for analog TV. And those are the most important. This is the minimum radius recommended per this type of cables. This is the radius per this cable, this is the radius per this one, this is the radius per this one, and this one. I have exactly the same information in this table that you have in your book. The coaxial cable loss. This is the more critical part of the coaxial cable. Depending of the coaxial cable selected and the coaxial cable connector, you have more loss or less loss. But in general terms, in order to minimize the loss of the cable, you should select the properly terminal, and you need to select the properly procedure to crimp it or soldering the terminal into the cable. The losses of cables, of connectors in the cable is 1 decibel per each 100 meters. The measure is in decibels per 100 meters. In the junction, in inline junctions, normally the loss is 0.5 decibels per each junction. Okay, the impedance are 50 or 75, and try to avoid excessive tight, excessive small radius, excessive bend on the cables, because you increase the loss. Here, for example, for marine VHF radio, normally is 3 decibels. For single sideband radios is 2 decibels. For cell phones, 3 decibels. In general, is in between 2 and 3 decibels, except for TV. TV is 6 decibels, is the higher. And those are the frequencies where each of those equipments operate. This is an important table. Try to keep this table because there are two NEMA questions on the training exam. Okay, my friends, and this is the procedure to calculate the signal loss. The total loss is the loss on the cable plus the loss on the junction. The loss in the cable is the loss in decibels per each 100 feet, depending on the type of cables, times the length of the cable, and all of this divided by 100. And the loss in the junction is basically the number of junctions times 0.5, and both measurements are in decibels.